Hello, welcome back. So we are solving regular expressions, and in this first example we are trying to find out an expression for the language of strings that have the substring 1011. So what is a substring? A substring is a part of the string. So this is our binary string, and at somewhere we have four consecutive symbols 1011 because this substring has to be there somewhere. On the left side, we can get more digits, and all those digits are going to be either 0 or 1. So we get 0 or 1 as many times as we want, including 0 times. On the right hand side, similarly, we can take 1 or 0 as many times as we want, including 0 times. So this is our answer, 0 or 1. Take that as many times as you want until you reach the first one of this substring. Then you get 1011, and then you can have as many 0 or 1 as you want. So any string that you can match with this pattern must have the substring 1011, otherwise that wouldn't match. And any string that has 1011 in it must match with this substring. So the two conditions are satisfying, so this is our answer. Next question. Now, this is interesting. This is the same question. Instead of substring, we just have subsequence. So what is the difference between a substring and a subsequence? Well, in a substring, 1011 must be consecutive. So 4 consecutive symbols. In a subsequence, we are going to get 1011, but there is no guarantee they will be consecutive. So there can be other symbols in the middle of those. Now, can you guess what is going to be our expression? First, answer me this. What can sit in these empty boxes? Well, as many symbols as we want, as long as the symbols are either 0 or 1. So we can get 0 or 1 in here, and as many of them as I want. Similarly, 0 or 1 here, as many of them as I want. 0 or 1 whole star, and so on. So the answer is, you can get 0 or 1, then there will be a 1, which is this one, and then we can have other digits, other symbols, and we'll get a 0, this 0, and then we can again have other digits, and then we get this one, and then again. This is a very correct answer, but there are other possible answers to this question which are even shorter, but I'm not going to get to that now. As long as you understand this answer and the logic behind it, that's going to be enough for now. Alright, so next example. We want all the binary strings that do not contain consecutive ones, so the string cannot have two ones side by side. This is a little different from what we have seen so far, so to solve this, let's look at the expression of all binary strings. So the only difference from this situation to this situation is that in that case, at every position of the string, we could either have 0 or we could have 1. There was no restriction. But in this case, we can have 0. 0 is fine. But every time I'm taking a 1, the next symbol must be 0. So the modification is going to be either I can take a 0 or I can take a 1. But if I take a 1, I have to take a 0 with it, right? That solves almost all our problems, but only one problem remains, and that problem is this string 0 1 0 0 1 0 1. Now let's try to match this string with this expression. This expression basically says I can take 0 or 1 0, 0 or 1 0, 1 or more times, right? So the first 0 I can take this one, right? For the second 1 0, I can take this one. Similarly, the next 0 can come from this 0. The next 1 0 can come from the next 1 0. What about this one? There can be a lone 1 at the end, right? We have made sure every time I'm taking a 1, a 0 must tag along with it. But what if the last one, the last symbol is 1? That 1 does not need a 0 to be valid. This is perfectly okay. To solve that, we must add another clause. So at the end, at the very end, we can have a 1 or we may not have that one. So either 1 or the empty string. This is our complete answer. This is really messy. Let's write it somewhere clean. We can take 0, we can take 1, but if we take 1, you have to take a 0. And repeat it as many times as you want, depending on the length of your string. There can be one single one at the end of the string. So this is our answer. Similarly, if we want the expression of all those strings that do not contain consecutive zeros, the same thing with the symbols being inverted. So we can take a 1, but if we take a 0, the next symbol must be a 1. Take that as many times as you want, but we must keep the option for the last symbol be a 0. So here is a 0, which may not occur. So this is our answer for this question. Alright, next example. We have to create an expression for the language of all binary strings in which the number of 0 is divisible by 3. So for an example, let's take a random string here, 1001011. In this string there are 1, 2, 3 zeros, so this is an acceptable string. We can have no zeros, that is 0 zeros, which is still divisible by 3. We can have 3, which is divisible by 3, 6, 9, and so on. So these are acceptable number of zeros that can occur in the string. Now pay attention in this part. As long as we have only ones, it's fine, because the number of zeros is 0, which is divisible by 3. Whenever we get the first 0, we must have 2 more zeros, so that combinedly they create a group of 3 and our number goes from here to here. When we get the fourth 0, there can be ones in the middle. Whenever we get the fourth 0, we must have 2 more zeros again, so that they combinedly create a group of 3 and our number of 0 go from 3 to 6. So you can see whenever we get one new 0, 2 more must appear. So it's like the one we saw a little while ago. As long as we are taking 1, it's fine. Whenever we are taking a 0, we must take 2 more zeros. But there is no guarantee that these 3 zeros are going to be consecutive. So in the middle of these zeros, there can be other ones. There can be any number of ones, including no ones. There can be no ones, just 2 zeros. So we have 1 star and 1 star here. And if we take a closure on top of this, we have our answer. We can take ones as many times as we want. Whenever we take a 0, 2 more zeros must appear, and in the middle of those zeros there can be any number of ones. So that is your answer. Great. So now let's look at one last example where we do something a little closer to our daily life. Now we are going to make the regular expression for all valid mobile phone numbers of Bangladesh. So what is the pattern here? We have plus 88 in the beginning, but this is optional, right? We may write it, we may not write it, and which means this may occur, or in this place nothing may occur. Or in short, we can just write plus 88 question mark. This is a shortened operator. We have already seen this. After that we have a choice of digits, right, for different operators. Oh no, after that we have 0 and 1. This will we don't need a bracket here. This is guaranteed to occur. After that we have a choice of digits. For Grameenphone we have 7 or 3, for Teletalk 5, Banglalink 9. This is not a straight line. For Banglalink 9 we have Airtel 6, Lobby is 8. So that's it. And after that we have 8 digits remaining, right? And those 8 digits can be anything from 0 to 9, and this is going to be to the power 8 because this is going to be concatenated 8 times. So this is our expression. Alright, so that's great, but let me show you something even nicer. I'm going to show you how you can actually use these regular expressions. So here I am with my browser. I have recently switched from Chrome to Edge. Highly recommended. This is really nice, the new Edge. Anyway, not important. Let's go to regaxr.com. This is one of many websites where you can search using regular expressions. I'm just trying to give you a demo of how things work. I have already a tab open where I have my desired text copied. Now this is where your text is and this is where you write your expression, and the program will match any string of this text that will match with your expression. So we have something about Dhanmondi takeout here, and let's say I want to find some phone numbers in here. So this is quite a large text and I don't want to look for the phone number manually. And the tricky part is I cannot search using directly the phone number because I don't know what the number is. That is why I am looking it up. I just know that this is a phone number. Well, you can say that you can search for like say 01 and it will give you a whole lot of other results. Like this is not a phone number. This is not a phone number. So let's just try and write the regular expression. So we have +88 in the beginning. Okay, so we have an error here because the plus actually also means the positive closure, right? So to distinguish an actual plus sign with a positive closure, we use the backslash. The backslash means that the next character should be regarded as a character and not a special symbol. Anyway, so we have the +88. I know that this is optional, so we need to add a question mark next to it. Then we have a 0 and a 1. This is guaranteed. Then we have a choice of operators. We have 5 for Teletalk, 3 and 7 for Grameenphone, 9 for Banglalink, 6 for Airtel, and 8 for something I don't remember exactly. What remains is the next 8 digits. So we are going to introduce a character class. That character class is going to be 0 to 9. This character class can occur 8 times. We generally write 8 as the power of this, but the notations are a little different here. We don't write it as a power, we write it as this. So this means this character class is going to occur 8 times. So as you can see, we have 3 matches for our phone number query in 0.2 milliseconds. So let's see, there are our 3 phone numbers. These are completely different, but one single expression matched with all of that. This is cool, right? So if you want to play with it further, you can just come to this website and try various regular expressions on your own. The notations are a little different than the one we learned because we only learned the basic ones, and there are a lot of shorthand operators, and you will find that in this website LexEgg. There is a long list of operators and notations here for regular expressions. How to write them, there are examples. You can just see what you need from here and try your expressions in this website. Okay, so that's it for today. I hope that was helpful, and I'm going to see you next week. Until then, take care and thank you.